Welcome to the Future Lab, the podcast exploring the frontier of autonomous science. I'm your host, Matthew, and in this episode, we delve into the groundbreaking work of the National Academy's 2023 report on NSF's DMRF program and its contribution to the Materials Genome Initiative. This report really highlights how we're accelerating materials discovery and impacting various sectors. It's a fascinating look at the intersection of materials science, AI, and robotics. The field of autonomous science is all about using AI and robotics to automate and accelerate research, right? It's tackling some major challenges in materials development, and the DMRF program is at the forefront of this. This report shows us how DMRF is working to integrate computation, experiments, and data, all to achieve that ambitious goal, developing materials twice as fast and at half the cost. Now, a really interesting aspect of this episode is that the script itself was partially generated using an AI language model. It's a perfect example of how AI is already transforming research workflows, even here in our podcast production. It's a testament to how AI is changing the very tools we use to explore these topics. So, let's get into the roadmap for this episode. First, we'll lay the groundwork with an overview of the Materials Genome Initiative and the role of the DMRF program within that initiative. Then, we'll dive into some concrete examples illustrating the impact of DMRF. We'll explore the current landscape of materials research, highlighting both the successes and the challenges. After that, we'll discuss the crucial aspect of workforce development, focusing on how we're training the next generation of materials scientists. And finally, we'll look at international collaborations and some key recommendations for the future, to really drive home how this revolution is shaping the world of materials science. So, are you ready to explore the future of materials science with me? So, we're diving into the heart of the matter now, the National Academy's 2023 report on NSF's DMRF program. The full title is quite a mouthful, but essentially, it's all about assessing how successful DMRF has been in meeting the goals of the Materials Genome Initiative. This report is really important because it looks at the first 10 years of this program, offering a valuable retrospective on its impact. The Materials Genome Initiative, or MGI, has this incredibly ambitious goal, to revolutionize materials development. It aims to do this by fundamentally changing how we integrate computation, experiments, and data analysis. DMRF, as NSF's flagship program within the MGI, is squarely focused on making those fundamental scientific breakthroughs and creating the tools to achieve this integration. The report's key findings are quite positive. It highlights DMRF's remarkable success in fostering truly groundbreaking research. We're talking about research that's not only pushing the boundaries of knowledge but also reshaping materials education and having a tangible impact on various sectors. But it's not all rosy. The report also acknowledges some gaps and challenges, and importantly, it offers really concrete, actionable recommendations for the future. So, what are we going to look at in more detail? We're going to examine DMRF's achievements across several key areas: computation, experimentation, data management, workforce development, and international collaborations. This detailed look will give us a much clearer understanding of how DMRF is not only meeting its goals but also shaping the future of materials science. And that naturally sets us up to examine these areas in more detail in the next section. Let's start by looking at DMRF's achievements in computation. Now that we've set the stage, let's delve into the methodology behind this National Academy's report. It wasn't just a quick overview, this was a comprehensive study. The National Academies assembled a team of experts who undertook an extensive literature review, meticulously examining existing research in the field. They didn't stop there. They also did a deep dive into the data from individual DMRF projects themselves, analyzing the results and impact of each one. To get a first-hand perspective, they conducted surveys of DMRF program participants, gathering valuable insights directly from the researchers involved. And finally, to ensure a well-rounded perspective, they conducted interviews with a range of stakeholders, including researchers, industry representatives, and policymakers. This multifaceted approach ensured a robust and comprehensive analysis of the DMRF program's impact. The report then categorized the impacts of these DMRF projects into 4 key areas: computation, experimentation, data management, and workforce development. This breakdown allows us to see how DMRF has advanced the state-of-the-art in each of these critical areas. For computation, that meant analyzing things like the use of high-throughput computing, the increasing adoption of AI and machine learning techniques, and the overall improvements in computational modeling. In the realm of experimentation, they assessed advancements in experimental techniques, looking at the development of high-throughput methods, new characterization tools, and novel synthesis approaches. For data management, a crucial element of the MGI, The report examined the development of new data infrastructure, explored data sharing practices, and assessed the effectiveness of data management plans. Finally, the report looked at workforce development, analyzing the educational programs, training initiatives, and the overall impact on the next generation of materials scientists. However, the report didn't just focus on successes. It also highlighted some key challenges. One major challenge was achieving full integration of the MGI paradigm. It's not simply about having great computational tools or excellent experiments, it's about seamlessly integrating them all together. Another significant hurdle was bridging the gap between fundamental research and commercialization. Getting these groundbreaking discoveries out of the lab and into real-world applications is a critical step. The report emphasizes the need for a robust data infrastructure. Without that, it's difficult to share knowledge and accelerate the overall pace of innovation. Similarly, the report stresses the importance of strong workforce training. We need to equip the next generation of scientists with the skills they need to fully utilize these advanced tools and methodologies. Throughout this deep dive, we'll make sure to present this complex information clearly, using analogies and plain language where necessary. We want to ensure everyone, from materials science experts to those new to the field, can understand and appreciate the report's findings. So, with this thorough understanding of the methodology and the challenges, we can now move on to a closer look at the specifics of the DMRF achievements. Let's start by looking at the advancements made in computation. Now, let's move on to the real-world impact of DMRF's advancements. This isn't just theoretical research, it's having a tangible effect across many sectors. The report highlights how DMRF's improvements in computational tools, experimental techniques, and data management are directly accelerating materials discovery and development. We're seeing this impact in areas like energy, where new materials are crucial for improving batteries and solar cells; in healthcare, with the development of new biomaterials; in defense, where advanced materials are essential for stronger, lighter, and more durable equipment; and even in consumer technologies. The report cites numerous success stories from DMRF-funded projects, showcasing how this research is translating into real-world applications. Beyond the specific applications, DMRF has fostered a completely new culture within materials research. It's no longer enough to work in isolated silos. This initiative emphasizes integration and collaboration across different disciplines. Think about it, materials scientists are now working hand-in-hand with computer scientists, data scientists, and engineers. This interdisciplinary approach is leading to faster, more efficient materials development, and breakthroughs that would have been impossible just a few years ago. And this new collaborative ethos extends to education and training. DMRF's impact is shaping how the next generation of materials scientists are trained, pushing for a more integrated and collaborative approach to research. Let's look at some specific examples. The report cites projects using AI to design new polymers. Imagine the possibilities there. And then there's the development of autonomous laboratories, using robotics and AI to automate high-throughput experimentation. This dramatically speeds up the testing and evaluation of materials. These aren't just incremental improvements, we're talking about revolutionary changes in how we discover and develop new materials. This is where things get really interesting. We'll be sure to explain the technical details in a way that's accessible to everyone, not just materials science experts. We'll balance the technical depth with clear explanations, so that everyone listening can understand the significance of these findings and the implications for the future. So, we've seen the practical applications and the broader impact on the field. Now, we're ready to discuss some of the key challenges and how those are being addressed. Let's move on to a discussion of the talent pool and the efforts to develop the future materials scientists. So, to wrap things up, let's recap the key takeaways from this National Academy's report on the DMRF program and its impact on the Materials Genome Initiative. We've covered a lot of ground today, exploring DMRF's achievements in computation, experimentation, data management, and workforce development. We've seen how this program is not only advancing fundamental science but also translating that research into real-world applications across various sectors. The report makes it clear that DMRF has made significant contributions to the Materials Genome Initiative's goals. But, the report also emphasizes that we're not quite there yet. There's still a lot more work to be done to fully realize the MGI's vision of dramatically accelerating materials development. The report's conclusions underscore the need for continued investment in fundamental science. We need to keep pushing the boundaries of our understanding of materials, developing new and improved computational tools and experimental techniques. And of course, developing a robust data infrastructure is essential to sharing knowledge and accelerating progress. Investing in workforce development is also paramount. We need to continue training the next generation of materials scientists, equipping them with the skills they need to work effectively in this new, integrated research environment. Looking ahead, the report suggests some exciting directions for the DMRF program. A greater emphasis on autonomous experimentation will undoubtedly accelerate the pace of discovery. Strengthening data infrastructure is crucial for seamless collaboration and data sharing. Think about the ability to easily access and analyze massive datasets in the future. And finally, fostering deeper collaborations with industry and other federal agencies will ensure that DMRF's research effectively translates into practical applications. The report highlights the importance of these collaborations to strengthen the impact of the MGI as a whole. This report truly underscores the exciting potential of the DMRF program and its contribution to the broader MGI goals. Thanks for joining us on the Future Lab. We hope this episode has illuminated the progress in autonomous science and the critical role of the DMRF program in accelerating materials discovery. Don't forget to subscribe and leave us a review. Your support helps us continue exploring the fascinating intersection of AI and scientific discovery. You've been listening to the Future Lab. Join us next time for another look at how AI is transforming research. Until then, stay curious.